Hello guys, hope you like my first video and now you are able to create a MCP server and set up your machine for creating your first data agent. This is the continuation of my last video, part 1 of building your first AI data agent with MCP, in which we created a simple MCP agent and connected with the Cloud IDE and covered some few things like project architecture walkthrough, what we are going to build, setting up your development environment where we install Python, Visual Studio, Cloud IDE, UV, and all those tools that is required. Then we had an understanding of the MCP server versus MCP client, and we discussed about DuckDB database fundamentals and set up our DuckDB into the system and building the weather forecast weather server functionality and connecting with the Cloud IDE and test our first MCP server. Now in this video we will build our first data agent using DuckDB. So how we will proceed on this is, first we create a DuckDB MCP server with the 2 to 3 tools and some prompts. So just to test it with the Cloud IDE. Then we connect it and then we'll add more tools into it. Then we'll discuss about how it is orchestrating between the tools and little bit idea about that, and then finally add more tools to make our data agents that can perform all the necessary data operations like the data ingestion, data integration, data cleaning, data transformation, and the data analysis. Let's jump into creating the data agent in Python. So we will use the same steps that we used to create our first agent. So let me open my Visual Studio here. Let's open the server. Okay, so here I'm into my MCP server folder, and now we'll create our DuckDB agent by using UV. So we'll create a UV init DuckDB. So here you can give any other name in place of DuckDB, but here I prefer DuckDB. So now it created all the files inside it, and in the same way we'll go inside this folder DuckDB, and then we create the virtual environment UV VE and V. Okay, so to activate this we can just copy this and paste this. Okay, now we are in our DuckDB environment. Now we'll add all the necessary tools that is required to create our data agents. So we need a DuckDB Python library here, and we need MCP CLI. So let's run this. So it seems like it is not allowing me to add the DuckDB because my project name is the same. So it is saying like considering the same name, it's shadowing the third party, and if the project name DuckDB is shadowing that, that will be considered renaming the project. Okay, so then we will rename our project. Let's see. Okay, now I renamed my server to DuckDB server, and now we are into this folder. Now let's try the dependency again. Okay, now it's working. Okay, now you see all the packages has been installed, and you can see it here, and now we can see whether the DuckDB is installed into it. Yes, DuckDB is also there. So now finally we'll create our Python file into this folder. Okay, so now Python file is also created, server.py. Now let's start our creating our first DuckDB server. So first we will add all the necessary imports that is required, and then we'll add our DuckDB. Now add some logging, so that will also help to in case of debugging. And now we'll initialize our server, that is MCP equals to fast MCP, and So this time we'll give our MCP server name. So we'll give DuckDB server. So you can give any other name here if you want. So now the most important thing is first we need to create our DB path where DuckDB will store the database. So you can give this till here. So basically this will create the DuckDB into your user directory. So here DDB underscore agent for.db. So why I'm giving for, because I already have three DuckDB agents created. So just to create a clean copy of it. Then after that we have to first create the connection. And we will pass DuckDB path here. Okay, so that's it. So in this code you first create the DuckDB path, and then you just connect your DuckDB. So you can also add some more code here, if the connection is already exist, then don't create the connection and all. So now let's start creating some tools which is necessary to create to connect with the Cloud IDE. First we will test it, and then we'll add more tools into it. So what is the necessary thing? What is necessary? So execute query is one of the thing that is really necessary to connect with the database and fetch the data from it. So first we will create our run query tool. So as I said, you have to use async function and run query str and string, right? So here so this is just a simple function where you pass your query, and when you pass the query, so you write a code to how to execute the query through the DuckDB. I have a code ready with me, so let me just paste it here. Okay, now let me just explain you about this code. So here I pass the doc string. So this doc string is really important for the MCP client. Basically, when MCP client interact with the server, what it will get is it will take the tool names and these doc strings, and based on that doc string, it pass to the LLM, and based on that LLM will decide which function, which tool need to be executed by the agent. So here we'll add MCP dot tool decorator, add MCP tool. Okay, so in this function we are just formatting our query, just to clean it and to make it in the format that DuckDB can run it. So so here we add some logging, and here if you see the connection.sql, so here it will execute the query and get the query result. So here there are some formatting that that I have done into this. So basically this is the code, and first we fetch the query result, and then we iterate this query result and convert it into the string, and finally we'll get the result output in the string format, which MCP client will pass to the LLM for his further analysis. Okay, so this is our run query. Now we'll create one more tool. Let me check. Yeah, so we'll create one more tool that is show tables. I mean, this is one of the necessary tool that requires to test our data agent. So in this it is very simple. I mean, this is my statement, and run query, why it is important is because whatever the query that you are passing, or the query that is generated by the LLM has to be executed by this tool. So what will happen is, if you are asking DuckDB to ask your agent to show all the tables into the database, so it will pass all these docker string to the LLM, and then LLM decide, okay, we need to execute show table function to show all the tables into the database, and then so this is the statement that it will execute by using our run query function. So this will work internally. Okay, so now these all are about our data agent tools. So let's create one prompt, because that prompt is also necessary, to take the actions, by our agent. So I'm just pasting it here. So here, this is our database prompt. So what will happen is, this is also the same, like, as like the tool, it will pass this doc string, and at the runtime, which prompt that need to be executed by the agent. So let's say if it is related to the database, then this is my generic prompt, where I have added the system message and the role of the user. So here you see the content is, you are the data agent that can perform all data engineering actions by initializing the connection with DuckDB server and provide several DuckDB SQL query tools. So these are the tools, that we are going to create in our DuckDB. Read query is read query is not that read query, it's run query basically. Okay, so run query is we have already created, and we have already created the show tables as well. So but now, so these are the prompts that is taken care by our agent. Okay, now let me show you once we run our MCP server. So this DuckDB agent, for how it will create and where it will create. So I show you here in my files. You see, I already have a DuckDB agent, DuckDB agent 2, DuckDB agent 3, but there is no DuckDB agent 4 here. So as I said, it will by default creating in your user directory in your system. Okay, now let's jump into integrate our DuckDB server with our Cloud IDE, just like we added our weather server previously. So let me show you. This is my Cloud IDE, and here you can see our weather server is already there, because we have added our cloud configurations like this, right? Now what we are going to do is, we will create one more MCP server string here, and we'll add it into this JSON. Okay, so one thing we missed here is, we forgot to add our main function. So let me add the main function here, where you can see our transport is stdio, and that's it. Also, let me show you, you can also start this server in your local, from your terminal as well, rather than connecting from your Cloud IDE. Let me show you how to do that. So you can simply use Python, and you can just run it by using python.server. Sorry, we didn't save that. Okay, so now let's start it again. Yeah, so my Python, through Python command also you can start your DuckDB server. My DuckDB server is already started, and let's see if it has created my, yeah, so it has created my DuckDB Agent for .db. So now go back to our DB server. Let's stop this, and we can delete it, so that once we connect it with our Cloud ID, so we can see it will create once we connect it with the Cloud ID here. So now we have created our DuckDB server tools, and we already tested it. It is working. Now let's integrate it with our Cloud IDE. Now let me open Cloud. And see, the weather is already connected, and now will add our DuckDB here. So what you're going to do is you can just take the same thing here, you change from weather to DuckDB hyphen, you can give any name here. Now the most important part is you have to change the directory, and the directory is DuckDB server. Okay, and here this is weather.py. In place of weather we created server.py. That's it. So now let's open our Claude desktop and see whether it is integrated into our Claude IDE or not. Okay, so now let's see whether it is integrated. Oh yeah, so our DuckDB server got integrated with our Claude IDE, and now you can see run query and show tables, which we have which we created here. Run query and show tables. So these two tools we already see here. Let's try this. Try and test this tool. So I gave you the command show all tables from database, from DuckDB database. Okay. Now it is calling show tables. It is finding some issue. So here it is saying there are no tables currently created in the DuckDB database. So let's first create one table. So we already have a weather tool here, right? And from the weather tool, here we already have a weather tool that we created. So last time we gave instruction to our IDE here, right? What is the weather forecast in New York and Texas? So why can't we just take this and give the command to the agent and add the information into weather table, or we can say and add the information into weather table in DuckDB. Okay, now let's see. Okay, first it is hitting get forecast. Now it is checking show tables. There are no tables in it. Okay, so now when LLM is passing, now agent pass all this information to the LLM, and LLM has created this query and pass it to the agent to execute this query. So now it is inserting the New York weather data. This is how it is inserting record by record. So it inserted the New York weather data. Now it is inserting Texas weather data, and finally it is providing the summary here, and that's it. So the agent has completed the task. So our task was to get the weather data of New York and Texas and insert it into the DuckDB database. So this task has been completed by the agent, and it has provided the summary with the number of records has been added by it. Now just to check what has been inserted into our DuckDB database. So now I'm closing our Claude IDE, and now I need to kill the entire operation of our all the instances of Claude, so that I can connect with my DuckDB. So here this DuckDB Agent 4 has been created. Now if I'm using CMD here, okay, so here first I'm using DuckDB. I'm just writing DuckDB, so it is connecting by using DuckDB.exe here, and then let's see how many tables has been created. Yeah, it is showing because oh, it shows 0 records. Okay, I got it. So basically by passing DuckDB we did not pass which DuckDB database we need to use. Now we'll pass again show tables. Okay, now it is showing whether table is created. Now let's see how many records are there. Select a star from weather. Okay, now you see it has created 5 records for New York and 5 records for Texas. Okay. Now let me close this so that we can use the same DuckDB database next time. Okay, so now let's create some more tools so that we can perform all our data related operations. So we already have the show tables and run query, these two tools that we created previously. So now we'll create more tools. Another tool that is describe table, right? So here this tool will help to describe into the what are the contents into the table and give the descriptions. And next one is we can use a summarize table tool. Here the function to compute a number of aggregates over a table, the function launches a query that computes a number of aggregates over all columns including min, max, average, standard deviation and all. So it's like it gives all the statistics when we use a summarize table. Okay, so like that I have one more function that is a create table from path, and it has a get table from path function. This is the helper function that also need to be created first. Wait. Okay, so now we have two more path, that is get table from the path. It will get the table, and create table from the path. So basically you have to pass from where you need to create the table. So now I have added all the tools that is available that requires to build our data agent. Let me just go through once again all the tools that we have already added, and there are some new tools. One is the show table to show the tables. One is the describe table to describe the table, the content of the table, and there is an inspect query, which the function to inspect a query and return the query plan. And so there is a run query. This is the important one, where which has been used by almost all the functions, because ultimately whatever the query that is sent by the LLM, the agent need to run that. So there is a summarize table. So here when we use the summarize table, the function launches a query that computes a number of aggregates, like it can give you the min, max, average, standard deviation. So basically this function will use to get the analysis from the table. So there is a get table name from path, create table from path, and so all those we will see in our data demo as well. So there is an export table to the path, and there is a local path to table, which you can load a local file into the DuckDB. There is a load local CSV tool. From the CSV file you can load this data. So basically you can give the command to the agent, so agent can take the CSV file and it can load it into the DuckDB database. So there are some paths, like it can also load the data from S3 path, or you can say from the web, or the CSV to the table. And like that there are some there is one more function, that is full text search, so which can take the full text search in a table column for a specific text or the keyword, right? So that is also useful. Now let's quickly see in our Cloud IDE whether all these new functions has been added, because previously we added only two functions or tools. So let me open my Cloud IDE, and now we'll see. Yeah, so now our DuckDB server, now it has 14 tools which we just see. Now you can see there is a show table, describe table, inspect query, run query, summarize table. All those tools are available, and also our weather tools are also available. Now the next is I'm just going through about the MCP servers which is already there in the MCP server GitHub page, and there are some third-party MCP servers. So we will just integrate that third-party MCP server into our Cloud IDE, and we'll perform some actions on it. Okay, let me go to the browser. And now we'll search for the MCP GitHub servers. Click on the first link, and now you see there are lots of servers are available into the MCP GitHub page. Now you see there are reference servers, Git tools to read, search the Git repository. There are some archived servers like GitHub, Git Drive, PostgreSQL, SQLite, all those. So like that, there are some third-party servers available. So these all are third-party server available. Out of this, I'm going to use financial dataset. Okay, so this is the financial dataset. So you can get some information about this server can give you multiple information about the stocks, like the current stock price, like the income statements, the balance sheet of the company, so on and so forth, and the crypto prices as well. Now let's quickly set up this as well into our current MCP server folder in VS Code, and connect it with cloud, and see some actions. Okay, now let's open VS Code, and now I'm into my MCP server folder, where I have my two servers already created. Now let's follow the page that I just show you, MCP server for now, financial dataset, and here is a guide how you can set up this server. So now first clone this website, clone this repository. Wait, oh, something happened. Okay, now it has cloned into the MCP server that we need to rename it. Let me rename to financial server. Okay, so now I renamed it to financial server. Now go to this folder, and we will run the same commands that we run for our weather and the DuckDB, that UV commands. Also we will follow the financial server setup guide. So here you can see we have to create an environment, virtual environment for the financial server, and then activate this environment. And okay, now the environment is activated. Now we need to add the necessary tools that is required for this financial server. Okay, it's done. Now what is the next step is you need to create the environment variable. So basically this is for the API key, and they already have this environment.example, but we will create environment variable where we will replace it with the key. So to get the financial dataset API key, you have to follow this link and create a financial dataset API. So for me it's already created, so I'm just copy it and add it into my environment variable. I'm just stopping this not to show my API key. Okay, now I have replaced my API key into the environment variable. So now let's go to this financial API. So this is the same type of code that you already develop in our weather and the DuckDB server. Like we have used the fast MCP. Here also they are using the endpoints where it will hit and fetch the data based on the API. So they already have some tools written like get income, how you have to pass the ticker value, like for Apple you have to pass Apple, APPL and the Google, and so basically these all arguments has been taken care by the LLM. So once you pass these tool details, you pass this doc string to the LLM, knows that you need to create these arguments, so it will pass the function name as well as the arguments to you, which you need to which will be taken care by the agent. Now there are other functions like get balance sheet, cash flow statements, current stock price. So we will be using current stock price in our demo, and also historical prices that you can check. There are some get the company news about the company, and there is some crypto prices also you can take from this, some historical crypto prices. So basically this one is like you can integrate this financial data set with your DuckDB, and on your you can also create some application on top of it which can fetch the data on a daily basis and insert it into the DuckDB. On top of that you can do some analytics. So like that, these all are the tools that are available, and this is the financial data set. Now let's integrate this financial data set with our Cloud IDE. So we will be using the same process that we used for our DuckDB and the weather data set. Now we'll give a name as financial server, and here we'll replace the folder name, and server is server. This is okay, fine. Now let's restart our Cloud IDE again. So go to our Cloud IDE and see whether the financial server are available now. Now let's do some operations on our financial server so that we can integrate our financial server with our DuckDB. So we'll give like get the current price, current stock price uh, of Tesla and Apple, and insert into table stocks table in DuckDB database. Let's see what all actions need to be performed by the agent. So now you see it is fetching the Tesla price, and it is fetching the Apple price by hitting the financial dataset APIs, and now it is showing the tables and running the query, and finally it is inserting the data into our stocks. Now these are the two data set that is currently inserting into this. So now it has perfectly inserted this data, and it is summarizing what all data has been inserted. So now we'll see what is in our DuckDB database, and now select star from stocks. Okay, so now it has added Tesla and Apple. So Google and Nvidia was already there. Now it has added Tesla and Apple also. So now let's move on into our data operations. So as we discussed, we are going to perform some data operation like the data ingestion, data integration, data cleaning, transformation, and finally do the data analysis on it. So let's start with the data ingestion first. So right now what we have is we have till now we have created three tools. One is our DuckDB server, which is our data agent. There is a financial server, which is the API tool, which can fetch the financial data set. There is a weather server, which is fetching the weather data set. And we have already see this weather data set already inserted into the DuckDB server. Now let's perform our first data ingestion action. Let's open my Cloud IDE. My data agents are ready, and now let's do some demo. So now our DuckDB server has 14 tools, and now I am going to ingest some data. I'm giving this command where I'm loading a CSV file. This is the orders data. Loading the CSV file from the CSV file and insert this data into orders underscore 2022 table. So now it is attempting all this and finally inserting this data into our DuckDB database. Okay, now it has successfully created. Now the second is now the similarly will create a 2023 data from the same from the URL, and now it is performing load S3 CSV to the table, and all those actions has been performed. So now finally it has it has created orders 2022 and 2023 data. Let's see the content in our DuckDB database. So select star from orders underscore 2022. Okay, now it has ingested this, and now select star from orders underscore 2023. Okay, now you see this data set. Here we have the same structure of 2022 and 2023 data, and now you can see there are some nulls and xxx are there, so that we will use in our data cleaning. So this is our data ingestion. Now let's move into data integration. So now we have created two tables, orders 2022 and orders 2023 table. Now by we are giving this task to the agent, where it will combine these two tables and load it into orders underscore all table. So now this table are exist. Now it is performing all those actions. So both tables have the same structure. Now it is going to create the table. Finally you see it is creating this statement, and okay, so successfully did this operation, and it has created orders underscore all table, where orders 22 has 7 records, orders 23 has 8 records, and total 15 records. Now let's see in our DuckDB. So select star from orders underscore all. Sorry, I was connected with the wrong database. So now in this DuckDB Agent 4, now this is orders underscore all table. Now you can see all the 15 records, you can see it here. Now as part of our next step is the data cleaning, and now we are going to perform some actions on it. So open our Cloud IDE, and now I am giving this task, data cleaning task, to my agent, like check the table orders, and if there is any duplicate records based on order ID, create a new column is duplicate and fill it with 0 and 1 value. Now it is start performing the actions. it is running the query and it is checking the schema and all, and now you see it has started creating the query where it get all the duplicate counts. And finally it is running the query, the alter command, where it is creating a use duplicate flag. And see, this is the it is inspecting the query where it has successfully created or not. And then finally the task has been completed by the agent, and now it is flagging order ID equals to 1104 2 records and 11052 records, XXS 2 records. Now this is the first part. Let's see the data into the database. Now we'll perform we'll connect the DuckDB database, and now you see it has added a is duplicate column, and it filled with zeros and ones where it is a duplicate. Now as part of the second action, we have to clean all the duplicate values. We will clean the null values and these triple X values. Now upon the Claude IDE, now next I'm giving another task, the data cleaning task, to the agent. Whatever the duplicate column that he has created, so remove all the duplicate values, and based on that we will see whether it has been removed all the records which are duplicated or not. Now you see it has started creating running all those queries where it is finding the columns, duplicate columns, and finally it is removing nulls. So now it is creating this query. The query is given by the LLM to remove the duplicates. So this LLM, this agent is smart enough to perform all the queries and remove all the duplicate records from this database table. So finally the data cleaning is completed, and it is giving you the summary. So finally what has been cleaned, it is showing that 9 clean records with no nulls and XXX entries, and it has removed all the duplicate records. So that is all about the data cleaning. So next we will perform our next action, that is data transformation. So in this data transformation we have a customer ID. I show you in our DuckDB. So we have a customer ID. In this it has two parts. For the first part is the ID and the second part is the name. So what we are going to do is we will split this column into the customer ID and the customer name, and we will remove this customer ID column. So this is one kind of transformation that we will do. So now you see split customer ID and this. Now let's do. Now it is sending this task to the agent. Now it is inspecting the query, and finally update the query. It is creating a split query here and running it, and finally it is altering the table, orders table, after splitting it, and that's it. Let's see in our DuckDB database table. Let's select star from. Okay, so now you see it has splitted customer ID, customer underscore ID into cust ID and cust name, and it splitted two columns. Now let's perform our last action, that is AI analysis. Now this is our last action, AI analysis, or we can say data analysis. So here what we are going to perform is do the analysis of the table orders underscore all and summarize data on orders and focus on any delays in the shipment, profits, and the and customers. So now see what all details that will provide by the agent. So now you see it is started creating the matrix where it is getting the count, min, max values from the orders table, and finally it is started creating some complex queries to get the statistics. So now it is displaying the orders analysis here. Now you can see the data set overview. There are total orders are 9 orders, unique tables, there are 7 unique customers, because we provide in our commands, like focus on delay in the shipments, profits and customers. So here it is delay in the shipments and giving the profit analysis, total revenue and all, and the customer analysis. So this is all AI analysis done by the agent on top of the table. So just imagine that you have more tables, more data into the tables. So and what will happen, this what the agent will do, it will take all the data and it can do a very good analytics on top of your data table. So that's it. So now finally what we have done till now is we have created DuckDB server, we have created our financial server and the weather server, and we integrated with our Cloud IDE, and we perform all the data operations like data ingestion, data integration, data transformation, data cleaning, and data analysis like AI analysis on top of it. So so that's it for now. So this is what we do with our Cloud IDE. So stay tuned, and you can subscribe my channel, and I will upload more videos, and we'll create some autonomous clients. So basically this Cloud IDE is the autonomous client, so that will build by using Python as well. And yeah, thank you so much. Thanks for your time, for watching this, for watching my video. Thank you guys.